All right, ladies and gentlemen, welcome to 7.2. What we're going to be doing today is what we call verifying trig identities. Basically, we're going to use what we did in 7.1 when we were simplifying our trig identities, and we're going to be showing one side of an equal sign looks like the other. All right, so let's take a look at a couple of definition things, what's going on here. So first, what does verifying involve? The goal, as I mentioned, is to make one side of the equal sign look exactly like the other side. Basically, making sure that that statement is true. We're going to use our trigonometric identities to simplify one or both sides of the expression. More often, you are going to use one side, not both. You are not, I purposely put this in all caps, bold, italics, underline, everything that I could do. You are not allowed to do anything across the equal sign at all. So there's no cross multiplication. There's no adding to both sides or subtracting. There's no multiplying or dividing to both sides. And many people just ask me this question. They just say, is there anything like any steps? Well, you guys might have seen from 7.1, those of you guys that have done it already, that it's really kind of hard to know what to do. And here's kind of what we kind of do as general guidelines. Work with one side of the equation at all times. Or at a time. Don't try to work both of them at the same time. Do one as far as you can get it, and hopefully that one will work out to make it look like the other side. If not, then you go back and work the other side to make it look like the first side. Always try to choose the more complicated looking side. I put that in quotes because sometimes it doesn't work that way. Sometimes it's not the more complicated side. And I actually have an example or two of that. What you want to do is you want to look for opportunities to factor an expression, not A and D. Here, I'll do this. An expression. Add fractions, square a binomial, or create a monomial denominator. Now, I know some of you are going like, I don't even know what those words are. Well, by this time in your math career, you should probably know what those terms mean. So if you don't know what they mean, look them up. Look for your opportunities to use your fundamental identities, the ones we used in 7.1. Really pay attention. I should have made this one bigger. Really pay attention to where you want to go. Don't try changing things into random functions. Try to change them into functions that will be useful to get to the other side of the equal sign. Somewhat of a last resort. If you can't think of anything to do, and if none of this stuff that I just said works for you, what you want to do is you want to try converting everything into sine and cosine. Like if you were given a tangent, you can change tangent into sine over cosine. If you're given cotangent, you can change into cosine over sine. Lastly, this last one is super important for every single one of you guys. You need to try something. You are not allowed to just go, hey, mister, how do you solve this one? I'm going to come over to your paper and I'm going to say, well, what have you done? You can't tell me nothing because you have to try something. You have to use some sort of identity and simplify something. And as the book likes to say, and as I like to say, even dead ends can help. If you reached a dead end, you realized, oh, I should have done this at a different time. All right, so let's take a look at a few examples. This first one is secant squared x minus 1 all over secant squared x equals sine squared x. So I'm going to look at the left side of this equal sign because it seems more complicated than sine of x. And I hope to be able to get it down to sine of x, sine squared of x. Now, whenever and I've been telling some people this when they ask me questions, whenever I see a square, I want to think Pythagorean identity. Not always, but I kind of lean towards those. And then if I see a square and a 1, I really lean towards the Pythagorean identity, so much so that it's usually the case that it is one of them. And I know secant squared minus 1 is going to be tangent squared. Okay, now I don't really know anything about tangent over secant, so I'm going to rewrite this as tangent squared times 1 over secant squared x. And that's true, right? Tangent divided by secant is the same thing as tangent times 1 over secant. And I still really don't know where to go, so what I'm going to do is I'm going to change everything to sine and cosine. So tangent squared becomes sine squared over cosine squared. And I know 1 over secant is cosine squared over 1 if you want to write the 1. And here I can cancel, and I'm left with sine squared x, and guess what? That's what I wanted. I wanted sine squared x, and therefore little check mark means we are done. We have verified that this statement is true. All right, I've got a few of these. I have here a 1 over 1 minus sine x plus 1 over 1 plus sine x. And I'm going to get, again, I'm going to use this because this looks more like the more complicated side. And right here I have two fractions that I could add together. So what I'm going to do is find common denominators. So the denominators are different, so I'm going to multiply by a 1 minus sign on this side and a 1 plus sign on this side. And let's see what we're going to get here. Let me go back to red. The left side here, or the left side of the fraction, I get 1 plus sine x over. When I FOIL these two things, I get 1 minus sine squared x plus, I get my 1 minus sine x over, again, 1 minus sine squared x. Now I have common denominators, and I can add them. So 1 plus 1 is 2. Positive sine x minus sine x is a 0. And in the denominator, let's just leave it like this for just a second. And then here, 1 minus sine squared x. Again, I have a 1 and a square, which means I want to look at my Pythagorean identities. And sure enough, it is 1. It is cosine squared. And anything over cosine is really secant. Well, 2 over cosine is actually 2 secant squared x. And that's exactly what we wanted in the first place. And we get a little check mark. We've verified this statement to be true. All right, let's try again here. We got, looks like the more complicated side is the left. Oops, missed my X there when I typed it. All right. So I have some squares and some ones. So I'm going to think again Pythagorean identity. Tangent squared plus 1 is secant squared. And cosine squared minus 1, if you were to manipulate the cosine squared plus sine squared equals 1, you would know that this is equal to the negative sine squared x. Well, in order to get tangent, I need sine and cosine. So I'm going to take secant, and I'm going to change it into 1 over cosine squared. I'm being multiplied by a negative sine squared x over 1, technically. I'm going to get sine squared x when I multiply straight across. And sine squared over cosine squared is tangent squared. Oops, sorry, I forgot my negative, negative, negative. And we get a check mark. We have verified this identity to be true. Let's keep moving right along here. Tangent plus cotangent equals secant cosecant. Some of these are a little bit more challenging than others, because right now you look at this and you go, I don't really have any Pythagorean identity. I don't really have any like big identities that I can use here. But what you do have is a sum of two fractions. Even though these don't look like fractions yet, tangent, instead of rewriting this, I'm just going to write it as tangent is actually sine x over cosine x, and cotangent is cosine x over sine x. So notice I'm taking the left side because it's a sum, which makes it a little bit more complicated than just a product. Now, in order to, hey, where'd my pen thing go? In order to add these two fractions together, I need to multiply to make common denominators. So I need to multiply by cosine. This one I need to multiply by sine. Go back to red here. When I multiply the left side by sine, I get sine squared x over kind of an ugly sine x cosine x plus cosine squared x over a somewhat ugly, again, sine x cosine x. All right, so when I add these together, I get sine squared x plus cosine squared x over sine x cosine x. And again, there, look at this. I have a Pythagorean identity. Sine squared plus cosine squared is 1. And technically right here, I can split this fraction into 1 over sine x times 1 over, whoa, what's going on there? Shoot. Where was I at? Man, that's irritating. Okay, I know where I was at, don't worry. 1 over sine x plus, sorry, not plus. One over sine x times 1 over cosine x. And you don't have to split this up if you know that this is this way, because remember we started with 1 over sine x cosine x. 1 over sine is cosecant, and 1 over cosine is secant. And you'll notice cosecant times secant is actually what we wanted, and therefore we have verified this identity. All right, I'm sticking this, being a little sneaky here, sticking it in the middle of the problems. You'll notice by the length of the video that the video is not done yet. But I know some people just looked at the very end of the video just to figure out the assignment. So let's see if they pay attention this time. All right, so those of you guys that are doing this, make sure you get this to me at the beginning of class. Do not do it at the beginning of class and expect me to take it from you. I want this done and turned in to me at the beginning. Just turn in straight to me and I will check them off. All right, let's keep going on these examples. So secant plus tangent equals cosine over 1 minus sine. This kind of looks a little bit complicated here. Let's start with the left side. Let's see if we can do anything to the left side. Well, secant is 1 over cosine, and tangent is sine over cosine. And the reason I did this is because I knew both of them had denominators of cosine. So what I want to do now is I want to add these two things together, and if I add them, I get 1 plus sine x over cosine x. Now, there is something really tricky that I could do to this side to make it look like the other side, but not everybody's going to be able to think of that. So here's one of those examples where I'm going to work with both sides of the equal sign. So I've done the left as far as I really can. So if I look at the right side now, I know cosine over 1 minus sine x. Well, one of the problems that we did in the last section was we multiplied by a conjugate down here. And the reason we did that was that it got a Pythagorean identity. And you'll notice that this one will as well. So when I multiply in the numerator, I'm not going to distribute. And I kind of mentioned this in the last video. I don't always distribute right away because sometimes things cancel. And the fact that I know where this one's going, I know that this does cancel as well. So I get 1 minus sine squared in this product here. Okay, my numerator hasn't changed. And now I know that 1 minus sine squared is actually cosine squared. And here, look at this. I have a cosine over cosine squared, which means I can cancel one of them. I'm left with a 1 plus sine x in the numerator and only a single cosine x in the denominator. And now that we have taken the left side and made it look like this, and the right side and made it look like the same thing, we have verified this identity. So this is one of those legal things. I didn't cross the equal sign, but I simplified each side separately. All right, let's see what I have next here. Cotangent squared over 1 plus cosecant. All right, I'm going to take, let's say, the left side. All right, now there's a few different things you could do in this case, but the one I want to do is I want to change cotangent because I know in the Pythagorean identity that cotangent squared plus 1 is equal to cosecant, which means cotangent itself is equal to 1, sorry, not 1, scratch that. It's equal to cosecant squared x minus 1, and I still have over 1 plus cosecant x. Now, here's not getting tricky, but something that you need to know how to do is you need to know how to factor. This is a square minus a square. So it's kind of like x squared minus 1. We know that that's x plus 1, x minus 1. Well, I can do that here as well, and things are nice when this happens. I get a cosecant x plus 1 and a cosecant x minus 1 all over 1 plus cosecant x, and cx. And notice I have a cosecant x plus 1 and a cosecant x plus 1, and I'm left with cosecant x, gosh darn it, minus 1. And you may not be able to see where that goes, so maybe you think, oh, that's as far as that one goes. Let's try the other side. So again, I'm going to work with both sides of the equal sign separately, and hopefully they come down to the same thing. Now, I really wanted to do this right side because I want to show you, whoa, what happened there? Get back there. I want to show you this particular idea that you can do. 1 minus sine x over sine x, I can split this fraction into 1 over sine minus sine x over sine x. Notice they have common denominators, which will still get me this left-hand piece. Well, 1 over sine is cosecant x, and sine over sine is 1, and now we have cosecant x minus 1 and cosecant x minus 1, check mark. We have verified this identity. All right, tangent to the fourth equals tangent squared secant squared minus tangent squared x. Wow, this one looks complicated. But you'll see here it's actually not as hard as it looks. So I have tangent to the fourth. So tangent to the fourth, bear with me here. And let's not do that. Let's look at the right-hand side, because the right-hand side does look a little bit more complicated. So we're going to say tangent squared secant squared minus tangent squared. You can do this from the left-hand side, and that's where I was going to go, but I figured let's look at the more complicated side like we've been doing. In this, again, I'm going to think of factoring. You'll notice here that tangent squared was in both of them, so I can factor it out. I have a squared function minus 1, which makes me think Pythagorean identity, and sure enough it is. This gets me tangent squared x times, tangent squared x, and squared times squared is to the fourth power. Now look at there, that one really wasn't as challenging as it may have looked with that fourth power on the tangent. All right, I think this is the last one here. Sine cubed cosine to the fourth is equal to cosine fourth minus cosine to the sixth times sine. And again, this one's not as challenging as it looks either. Doesn't really matter which side you work with here. Both side looks a little bit complicated. I'm going to try to show you how to do it from the right-hand side, even though I think that might be the more challenging way to do it. I kind of like the left side, but I want to show the right-hand side. I'll show both. All right, so I have cosine to the fourth x minus cosine to the sixth x times sine x. You'll notice this thing inside the parentheses has at least 4 cosines to them. So I'm going to factor out a cosine to the fourth x. And I get 1 minus cosine squared. And 1 minus cosine squared is sine squared. We know that. And looky there, we have cosine to the fourth times sine squared sine, and that gets me a cosine to the fourth x times sine cubed x. And that would verify it from the right-hand side. And you'll notice that going from this side, the left side, is just the reverse order. I would start with cosine to the fourth times sine cubed. I would factor out a sine squared. I would break up sine to the third into sine squared sine. Sine squared would become 1 minus cosine squared, and then I would distribute. So notice that the left side is just the reverse of the right-hand side. And that should be the case for every single one of these, by the way. All right, this one is almost exactly the same way. So what I'm going to do is I'm going to head off to the assignment here. And you already saw, if you watched the video, the stuff to do in this assignment. Here is the full assignment, page 543. This is your 10-point assignment. Due at the end of the class on the second day of class. And of course, you can add some extra bonus points to your grade. Little buffer there to help you out if you do the entire assignment. And yes, it's a lot. And yes, it will be challenging. And yes, some of them are hard. Maybe not quite as easy as all of the ones that we did on the assignment today, or on the lesson today. All right, so there you go. I will see you guys later.